Hi girls. I'm going to put up the answers to your homework, and for most of you, you had no problems in creating this table, so let's go straight in then to patterns that are just have numbers. So I'm on page 399 and I'm taking a look at question 3. There's a misprint when I went to do it. That should have been 37 for this one to work out. Okay, so it's just they mistyped it. Okay, so this was the list of numbers I was given. So I changed that list of numbers into creating a table like you were doing for me for homework. So I put each of them down, minus 3, 4, 13, 24, 37. And I say, well, what's the difference between minus 3 and 4? It's 7. Difference between 4 and 13, 9. 13 and 24, 11. 24 and 37, 13. Okay, so straight away, the first differences are not the same. So this is not a linear pattern. I then go to the second differences. What's the difference between 7 and 9? It's 2. Difference between 9 and 11 is 2. Difference between 11 and 13, it's 2. If all of the second differences are the same, it's now a quadratic pattern. So the first question I'd be asked is, how do I know it's a quadratic pattern? I know it's a quadratic pattern because the second differences are all the same. Okay. I'm then going to be asked to write a general formula. So I'm going to be asked, and this is the hardest part of this chapter. After this, we've done most of the other stuff. To be honest, we did a lot of quadratic stuff before your mocks, and there's nothing hugely in it. Okay, but the next thing we're going to be asked for is a general formula. So the general formula for any quadratic is an squared plus bn plus c. And we've met this before, where we had ax squared plus bx plus c, and we used the minus b formula. So this is a general formula for any quadratic. When we're using it in terms of patterns, this is the form we put it in. So it's a, b, c, again across the line. Okay, why not x squared? Well, in most of the patterns, they're going to ask you for a general formula and they're going to call it Tn or Sn. So we use n instead of x. Again, that is just a letter. So that could be any letter you wanted it to be. You could make it x if you want it. But for patterns, we've always used n. So in the previous linear ones that we took a look at, we always used n. So we'll keep using n here. Okay. Your book then does a really nice stepwise here. So you see the blue box on page 396. So that's the notes that I'm going to be working around. Okay, so the first thing it says, find the value of the second difference for this particular sequence. So my second difference is equal to 2. Step 2, have this value to find a. So a now is equal to 2 divided by 2, which is 1. So my a is equal to 1. Okay. Step 3, substitute this value of a into the general formula, which represents any term in the sequence. So now it's saying to you, substitute in a is equal to 1 for any term that you've got here. Now you could choose minus 3, 4, 13, 24, 37. I'm not going to choose minus 3 because I don't like working with negative numbers. So I'm going to choose 4 because it's just an easier number to work with. Okay. So that's the second term. So this would be term 1, term 2, term 3, term 4, and term 5. So I'm going to work with term 2. I could work with term 1, but I'd have to work with a negative number and I don't want to do that. Okay, so I know that term 2 is equal to 4. And I'm going to substitute in now for my general formula. So my Tn is going to be equal to 1n squared, because a we found out was 1, okay, plus b times 2, because I'm on term 2, okay, and that should be 2 squared, plus c, and the answer to that is equal to 4. Okay, so this is the formula. I'm working with term 2, so I'm working with term 2 because term 2 gave me a nice answer. So everywhere there was n's, I'm changing them to 2. And I worked out a, and I told you that a was equal to 1. So I've substituted all this in. So now what do I get? So I'm trying to work out what I get now across here. Sorry, it's a bit messy, girls. Holding this just doesn't work for me. So it's 1 times 2 squared. So 2 squared is 4 plus 2b plus c is equal to 4. So I'm going to put the letters on one side and the numbers on the other side. So to move this 4, I'm going to take away 4. So it's 2b plus c, 4 minus 4. So I'm taking away 4 from both sides, is equal to 0. So that's my first equation. Okay, or my equation A, for example. Okay. The second thing then, so I've done step 3. Step 4, use any two terms to form two equations. Okay, so I can do any two terms that I want. I've already done 2, so I'm also going to go with term 3. So if I go back to the sequence that I had on the previous page, I'm going to take term 3, which I said was 13. Okay, so I know that term 3 is equal to 13. So again, I know that I'm subbing in now to this formula an plus bn plus c. I know that for term 3, I've got 1 times 3 squared plus b times 3 plus c, and I know that the answer is equal to 13. So it's 9 plus 3b plus c is equal to 13, and I'm going to move the 9. Okay, so it's going to be 3b plus c is equal to 13 minus 9 is 4. Okay, and this is my second formula. Okay, now I have 2 formulas and 2 things I don't know the value of. So if you remember, when you have 2 formulas, and sorry girls, right way too big, 2b plus c. 2b plus c is equal to 0. So that's the one we had on the previous page. And the second one I've got is 3b plus c is equal to 4. So now I have 2 equations, equation 1 and 2, and I want to know b and c. Okay, so this is a simultaneous equation. Okay, I want the same number but different signs in front of that second letter. So normally we'd have it as a y, but here we're using a's and b's. And again, then the what you call it should not matter, even though it does, we know that. The letter that you choose. Okay, so let's take a look and see. So I'm going to keep equation 1 exactly as it was. 2b plus c is equal to 0. And for equation number 2, I'm going to change all signs across the line. So it's going to become minus 3b minus c is equal to minus 4. So I've gone minus, minus, minus. Okay. We now add our 2 equations together. Our c's disappeared. So 2b minus 3b is minus 1b is equal to minus 4. And then plus b is equal to plus 4, changing the signs across the line. So now we know a is equal to 1, b is equal to 4, and we're just looking for c. So we take your equation 1 again, which is 2b plus c is equal to 0. And everywhere you've b, put in your 4. So 2 times 4 plus c is equal to 0. 8 plus c is equal to 0. C is equal to minus 8 because you move the 8. So c is equal to minus 8. And now you go back to your general formula. So it's Tn is equal to an squared plus bn plus c, and you sub in your values. So it's 1n squared plus 4n, changing b to a 4, and plus a minus 8, which is minus 8. So rewriting that, 1n squared. You don't need the 1, but you can have it, plus 4n minus 8. And that's the answer to the general formula. So you have to do a simultaneous equation with this one. It's not easy. It really isn't. Okay. You're probably going to need to see another one, but what I'm going to do is if I can see where you're going wrong, then I'll have a better chance of being able to pick up what you need me to do. So I'm only going to ask you to try one, because no point doing a load of them to find out that you're doing them wrong. Okay, so you're on page 399. I'm going to ask you to do question 3, and you're doing D part 2. So the one I've just done, and you're following the same steps that I have. Okay, so it's this one, 1, 3, 7, 13, 21. Now for this one, in the last one, we started with term 2 because we didn't like the minus. You could start with term 1 and do term 2. You could do term 2 and 3 like I did in the last ones, term 4, term 5. First job, which I think you should be able to do, is create the table here, which most of the grade goes for anyway. Okay. And once you've that done, then can you pick out the second difference for me? Can you halve it? So you're following these steps. Step 1, take your second difference, halve it. And if you can get to there, and then give this a try, give it a bash. Okay, and let's see where you're going wrong, and then I'll have a better chance as to know what you need me to do. Okay. All right, best of luck with it, girls, and I'll talk to you soon.